Hello everyone, once again on behalf of the State Council of Science, Technology and Environment, I invite all the viewers to this online class, especially for the class 10 students. Today we are going to do a new chapter called Metals, Non-Metals and Metallurgy from Chemistry textbook, which is under the MBOSE syllabus. Let us start this chapter. Now, in any matter that exists, either in the solid state or in the liquid state or maybe in the gaseous state, those matters, they are made up of elements. So elements, they are the building blocks of matter. And on the basis of the common physical and chemical properties, the elements are divided into two main classes. The elements, on the basis of the common physical and chemical properties, they are divided into two main classes, which we call metals, and the other class, which we call the non-metals. So first of all, let us study the difference between metals and non-metals based on the common physical properties of metals and non-metals. So first of all, let us have a look on the basis of physical properties. Those elements which are metals, they are generally solid materials which are hard, they are malleable, ductile, have high melting point and boiling points, and they are good conductors of heat and electricity. So those elements which share these common physical properties, they are classified as metals. So those other elements which do not possess mostly of these properties, they are called non-metals. So non-metals means those elements that do not possess mostly the characteristics of metals. So non-metals, they are generally soft, means they are not malleable, not ductile, they have low melting point and boiling points, and generally they are bad conductors of heat and electricity. Here, when we say that metals are malleable, by this word malleability we mean that it is the property of an element by which it can be beaten into thin sheets. So some metals, as they are hard, so it may take more pressure, but it can be done to convert them into sheets. And this word ductile, ductility, it is the property of an element by which it can be drawn into wires. So if you take an example as coal, so coal can be beaten into sheets and it can also be converted into wires. So on the basis of physical properties, the elements, they are classified mainly into these two classes, the metals and the non-metals. But now here we will study about one important bond that exists between metals and non-metals, which we call the ionic bond. Let us have a look at this bond that exists between metals and non-metals, called the ionic bond. What do we mean by ionic bond? It is a force of attraction between metals and non-metals. And as the name suggests here, ionic bond, so here there will be formation of ions. So here there will be formation of ions. And as there is formation of ions, which means that there will be losing of electrons and gaining of electrons. So here, that is, there will be losing and gaining of electrons. If an element loses electrons, then it becomes a positively charged quantity, and if it gains electrons, it becomes a negatively charged quantity. Let us understand more clearly about this ionic bond by the help of an example. And for that, we will look at the formation of sodium chloride. Let us have a look at the formation of sodium chloride molecule, which is NaCl. First of all, we will write the electronic configuration of sodium and chlorine atoms. The atomic number of sodium is 11 and that of chlorine is 17. So the electronic configuration would be for sodium, following that pattern that we have, 2, 8, then 10, then 1 more. This will be the K shell, L shell, M shell. And for chlorine, 2, 8, 10, but 17, so 7 more. So this is the K shell, L shell, and the M shell. Here, sodium is a metal, and the size of the sodium atom is very large. So this outermost electron, which is the valence electron, is not tightly held to the nucleus. So this sodium atom will readily lose this outermost electron, so that it will complete that octet state. So that if it loses this outermost electron, then the outermost shell will be the L shell, and it will have 8 electrons, which is stable. But on the other hand, this chlorine atom has 7 electrons in the outermost shell, and it does not have the tendency to lose these valence electrons, but it tries to gain 1 more electron so that it will complete that octet rule, so that it will have 8 electrons in the outermost shell. Let us represent this in the Lewis dot structure. We have sodium atom, and the electrons in the outermost shell is only 1. So let us represent an electron by 1 dot. And for chlorine atom, there are 7 electrons in the outermost shell. So sodium atom, when it gets close to chlorine atom, it will donate this valence electron to the chlorine atom, so that it would become stable, and chlorine also would become stable. So here, when this sodium atom loses 1 electron, it will become sodium plus, which is a cation. Here, the electronic configuration in here will be 281, but when it loses this 1 electron, it will be 2,8, which is the electronic configuration of a noble gas element, which is stable. Here for chlorine, if it gains this electron, from the sodium atom, it gains one electron. It will become chlorine anion, and here the electronic configuration for chlorine element will be 287, but if it gains one more electron, it will be 288, which is again the electronic configuration of a noble gas element. So in this way, sodium atom donates electron, and that donated electron will be gained by the chlorine atom. So in the dot diagram we have sodium. When it gets close with chlorine atom, we will get this. Sodium will donate this electron to the chlorine atom, so it is positively charged, and chlorine atom will gain that electron which is donated by the sodium atom. So it has already 7, and with this one it will be 8, and it will be a negatively charged quantity, or we just write this simply as NaCl. So this is how the ionic bond is formed between sodium and chlorine atoms. And now in general, the metals possess 1, 2, or 3 electrons in the valence shell. But the non-metals, they possess 5, 6, or 7 electrons in the valence shell. So the metals, as they have 1, 2, or 3 electrons in the valence shell, they will have the tendency to lose these valence electrons, so that the outermost shell will be having that 8 electrons. And for non-metals, as they already have 5, 6, or 7 electrons in the valence shell, so they will have a tendency to gain more electrons, so that the octet state will be completed. So this is what is happening in ionic bond. Metals, they donate electrons, and the non-metals, they gain electrons. Now let us have a look at some of the properties that the ionic compounds possess. Now in ionic compounds, as we have that the force of attraction is between oppositely charged quantities. So the force of attraction is very strong, and so that's why the ionic compounds would possess these properties. As the force of attraction between the oppositely charged quantities are strong, so they are generally hard solids. And as they are in solid state, so they are non-volatile, and they have high melting points and boiling points. And again, as we have seen during the formation of sodium chloride molecule, as there are formation of ions, so they will be soluble in water, and finally they are good conductors of electricity. So these are some of the properties that's possessed by the ionic compounds. So for now, we will stop here, and next class we will try to study about the chemical properties and why do we need to study the chemical properties. So I hope you have understood this one. We will see again next time. For now, thank you.